So I'm Shachar, I'm a CI engineer here at Wix, and here we'll talk about the next generation build system. I'm going to talk about the next generation build system and how it's going to make your life better, our lives better. But before I'll talk about that, it's important for us to understand why we went looking for a better build system. What is the current build system we have, and what are the problems we have in it? So we start very basic, where on the one side, we have Neta, our developer, and on the other, we have the production server. Neta just made a brilliant change to her code and wants to ship the change into production. But Neta, just like any other responsible developer at Wix, asks herself, does she have any bugs? Is she breaking someone else's code? And so the build system gives her an easy way to ship her code to production while providing her tools to validate its correctness. Two important elements in this system would be the build tool, a tool that allows her to define how to build her project, and then run all the tests, and the build server, which is a remote server that executes stuff. In our context, it executes the build tool, giving feedback to Neta, but also acts as a gatekeeper, allowing code to proceed to production if the build passed, or preventing code from getting into production if the build failed. Given those tools, Neta can answer her questions by first running the build tool locally on her laptop, and then letting the build server do the same. We say that a good build system allows a fast and correct feedback. Fast, because we know we want to keep our high velocity, and correct, because we don't want to put any bugs to production. So that was a super basic explanation of a build system. And now let's examine the current build system we have. So I'm going to talk specifically about the build system we have for the JVM, for the backend. But I'm sure this story would be familiar to all of you in this room. So for the JVM build, we have Maven as our build tool and TeamCity as our build server. Maven is an open source build tool that has been here since 2004. It allows me to split my project into modules. Each module will have build definitions, dependencies, main code, test code. When I execute Maven on a single module, it will first fetch all the dependencies, compile the code, and run all the tests. When I execute Maven on a multi-module project, it will first analyze all the dependencies, determine the execution order, and then execute itself on each module one by one sequentially. Matching Maven is TeamCity as our build server. TeamCity is a commercial tool by JetBrains. It allows me to distribute jobs among a pool of agents which we pay for. For the backend build system, we use TeamCity jobs to run Maven, and we define dependencies between those jobs, such that after running one job, it will know to trigger another job, and then all the jobs that depend on it, and so on and so on. To make sure we always build against the latest dependencies, we configured TeamCity to block all the jobs while their dependency is currently building. So, can this system really be fast and correct? If my project is small enough, not a lot of modules, not a lot of dependencies, not a lot of code, Maven can really bring a really quick and correct feedback, and TeamCity would have no problem to do the same. But we all know that Wix is not small anymore. Projects get bigger and bigger with more and more modules, and the dependency graph becomes more and more complex. So it's no longer an easy task to get fast and correct feedback. How bad is it? Locally, we have to compromise between fast or correct. Fast meaning running the build tool only on a subset of the project, losing the feedback about other modules that I might have affected. Correct means that I have to run the build tool from the root of my project, paying the price of a full build, which in some projects at Wix can cost even more than 1 hour, even close than 2 hours. For the build server, we cannot really do this compromise, and we have to have a correct build. And so the CI team applied several optimizations, which one optimization that I'm going to talk about is to reflect each Maven module into TeamCity job and Maven module dependencies into TeamCity dependencies. Thus, we utilize TeamCity distributed parallel work to make the build a bit faster. But the truth is that it's not fast enough. It's slow, and in a lot of cases, it's even blocked. 4 reasons that I'm going to list about why the builds are blocked. First, and I think this one is the most understandable, is that my job is currently blocked because a job that I depend on is currently building. Second, sometimes TeamCity is just out of free agents to run my job, and I'm stuck in a queue waiting for the next available agent. The third, and I don't know if all of you know this reason, is that currently we configured in TeamCity over 2,000 jobs. Even TeamCity architects said that they never expected their system to see such scale. So sometimes just to digest what needs to be run after a change can take TeamCity over 10 minutes. During those 10 minutes, it will not trigger any job. The fourth reason, and this is more of a process issue, is that sometimes my code depends on a broken piece of code. During which I think this one is one of the most frustrating reasons to be blocked, because I'm just waiting for someone to fix his code. 2 weeks ago, by the way, I had the chance to see this in action. Unfortunately, I was the break inside of this situation. So it wasn't very pleasant. So we wait and we wait and we wait for my code to get feedback, for my code to get into production. Developers say that waiting for a build is one of the biggest bottleneck they have when they want to release a new code. And if I look at the CI team ticketing system, waiting for a build is one of the top 5 issues. It's obvious that we had to look for a solution. And we went looking for a solution. Looking for a better build system, a better build tool, a better process, a better build server, one that would give us fast and correct feedback, one that would never have us depend on a broken piece of code, and one that was actually designed to scale, to work with our ever-growing number of components we have here at Wix. And so we looked for different, I ruined the punchline, but we looked at different solutions, and we looked at different companies and did some POCs and came back with Bazel, a modern build tool that can actually solve a lot of our problems. Now, I know a lot of you already heard about Bazel in different forums, in server guild days, and in the next slides, I'm going to offer a new explanation about what's Bazel and what makes it so unique, and I hope it's gonna help you fix stuff in your head. So Bazel is a build tool that was an internal build tool in Google. In 2015, they decided to give it to the open source community. While other build tools in the market make you do the compromise between fast and correct, Bazel comes with the promise that it can handle hundreds and hundreds of components, like in Google, while keeping the build fast and correct. So Bazel tagline is fast, correct, choose to. Now I'm going to drill into the fast and correct. And before we'll talk about the fast, we have to agree about why Bazel is so correct. So Bazel is a functional build tool, meaning that the output of each execution is a direct result of the input of the execution. The sources, the dependencies, the settings, which is the platform, the compiler, everything that is defined within Bazel files. To make sure nothing else affects the output, Bazel wraps each execution inside a sandbox, an isolated environment in which the execution can only access resources that were defined in Bazel files. Bazel also gives this execution isolated file system and isolated networks, so 2 executions that run on the same time would not step on each other. To make sure that the build is very hermetic, Bazel disables by default access to the internet, for instance, or access to shared file system. So that really promises that the builds of Maven are reproducible and correct. Moving on to the fast, what makes Bazel so fast? First, Bazel lets you break your project into very small units of build. When you have a small unit of build, the execution time on each unit is very short, and each change on a build unit has a smaller impact. Second, when you run Bazel, the first thing it does is to run a very smart analysis on the build units, and then determine the execution order. Then it will utilize all of your computer CPU, unlike Maven that will utilize only one CPU, to make sure it will run as many build units, as many executions as possible in parallel. That makes Bazel a lot faster than Maven was ever designed to be, and even Bazel with the optimization that TeamCity brings it. The third, and I think this is the killer feature of Bazel, is the correct incremental build. And what do I mean by that? Sometimes we just finished to build all of our project, and we just made a small change that affects a small amount of modules in my whole project. So rebuilding the whole project is a waste of time, of course. A lot of build tools offers some kind of cache to allow you to avoid that. Maven also gives you that solution. But we all know that if we really want to have a correct build, we don't use that. Why is that? Because when you use items from Maven cache, you don't know if the input that created that item was actually changed. So sometimes you can find yourself with outdated items when you look up in Maven's cache. So we don't use Maven cache, and if we want to have a correct build, we pay the full price of a full build, and don't use the cache. Bazel takes a much smarter approach towards cache. Before you go to the cache, you check the hash that made from the input that created that artifact. If the cache is lacking the item that matches that hash, you would just rebuild and make sure that the items in the cache are always in sync with the input. And so you can trust the cache. That feature alone can save you a lot of time on the build time. And you can actually trust the build. You can actually do incremental build also on the build server. So you work less and stay correct. So how much faster Bazel really? Let's have a look. So we took a small project Wix framework with over 100,000 lines of code that is divided to 207 Maven modules, and migrated into Bazel. In Bazel, it was a little over 2,000 Bazel targets. In the next screen, we'll see Bazel and Maven running side by side. And I want you to note how long it takes each tool to digest what needs to be built and starts running. So yeah, that's a clean run, it's important to say. So on the left, we have Maven. On the right, we have Bazel. Both tools are trying to digest what needs to be built. And after just few seconds, you can see that Bazel already starts running. Maven, on the other side, takes it about 15 seconds before it even starts running. On the right, you can see that Bazel tries to run stuff in parallel, and Maven is still processing. So if I jump only 1 minute later, you can see that Bazel now utilizes all 8 cores of the machine, running unit tests side by side with end-to-end, and building some other units. And Maven is barely on the 6th model out of 207. So Maven is only 4% done, while Bazel is already 10% done building the project. If you look at the final numbers, you'll be amazed of how much Bazel saves time in correct build time. Building framework, having a correct build from framework takes 45 minutes if you do that with Bazel. But if you do that with Maven, doing that with Bazel takes me 20 minutes. But an actual run that is incremental takes me on average 5 minutes. So we now all agree that Bazel is both fast and correct, and now we need to match it with a good build server experience. So we can just take TeamCity as a build server connected with a very strong build machine with a lot of CPUs and run Bazel on it. But the problem with this solution is that it's super expensive, Having this machine is super expensive. If we don't have enough machines, we're prone to failures, and we're still limited by the number of CPUs that the machine has. If we even overcome all of these problems, we'll have problem to read the build result, because with Bazel, one job would build not only your project, but also even all of Wix. Luckily for us, Google is about to release a new service that would allow me to break the limit of the number of CPUs I have and the need for a strong build machine. With this service, I can enjoy three major features. First, I can utilize the fact that each Bazel execution is done in an isolated environment. And instead of running the build locally, I can delegate the work into remote worker. And this new service by Bazel gives me a pool of hundreds of remote workers to do the work for me. So I'm not limited anymore by the number of CPUs I have. Second relates to viewing the results, which I think means viewing the test reports, viewing the build log, seeing the artifacts. Think about it that with Maven, you had one job per Maven module. But with Bazel, you have one job per project, or even one job per all of Wix. Think what a nightmare would it be to look at the build log that builds all of this. Well, this new service by Google gives me a new results UI that allows me to filter to allow me to view the results divided by Bazel targets, and then filter to see only the targets that interest me. And then for each target, I can see the build log, the test results, to get the artifacts. It's very easy. The third feature, which I think is the killer feature for that service, is the remote cache. So all the remote workers that service gives us share one remote cache that works with the same correctness as the local cache. And what makes this feature so great is that not only the remote executor can enjoy this cache, but also our local executors. So our local builds become even faster than before. So we have Bazel as the build tool, and we can enhance it with the remote execution. We still need some server to orchestrate the main Bazel process. And of course, we can take TeamCity, just connect it with an agent, and then use the new service to run Bazel in an enhanced mode. But do we really want TeamCity to be in this game with its limited number of agents and the maintenance cost we have on it? Google Cloud provides another tool that just completes the picture, the Google Container Builder. Essentially, it's a build server as a service on Google Cloud. It gives me essentially an elastic, unlimited number of build machines. So no more blocking because we don't have free agents. So with the power of Bazel as the build tool and the remote services provided by Google, we can actually solve another blocking issue we have here at Wix, depending on a broken piece of code. So why does it happen? Let's say that I get a good feedback locally, and I push the code to master. The build server disagrees with me and blocks the build from getting into production. It finds a problem in my code. But at this point, master branch is already broken, and all the rest of the developers get the master branch. A better solution would be for me to push the code into a pull request branch and have the build server act not only as a gatekeeper to production, but also as a gatekeeper into the master branch. And then other developers can trust that the code they get from the master is always green. That process is actually implemented in the current build solutions for some of the teams, but they have to pay twice as much time on running the build once on the pull request branch and then on the master branch. With the new remote execution service, we know that once we ran the build on the pull request branch, everything is saved in the cache using the hash of the result of the sources, and then running the build again on the master branch would take no time because everything was saved in the cache. Question? Good question. If there's a failing PR that is in the cache, people get wrong code. So the cache works according to the sources. So a failing PR would not, so no one would really consume a failing PR because the master code is different than the PR branch. Given this power of this new system, we can actually apply this good process for all of Wix repositories, so you never have to depend on a broken piece of code. So we had a dream, and in this dream, we have a build tool that we can trust to give us fast and correct feedback. We have a build server that gives us fast feedback and allows me to GA in time, and a master branch that is always protected. So GAing my code is not a problem anymore, and we're all happy. But how do we make this dream come true? Because we need to move from one build system to another, and this build system is rather new. So 3 things that we did in the past 2 years, and I'm oversimplifying what we did because this is not the topic of this talk. First, we built a build tool that migrates Maven project into Bazel. That migration tool does almost all the work needs to be done in order to migrate the project, and it raises a lot of interest in the general community of Bazel in the world. Second, we had to make sure that Bazel works great with our technologies. So we contributed to several Bazel open source repositories, starting with Bazel Scala extension, and then IntelliJ Bazel plugin. And as very typical to Wix, we created, together with Google, a testing framework for Bazel extension. Third, we had to make sure that our internal CI/CD systems, like Wix Lifecycle, works great with a new system like Google Container Builder. So I bet you're all wondering at this point, how close are we? I mean, when will we have this dream? And the answer is very close. And I'm going to show you now deploying a service, deploying a new code using this new system to production, using Lifecycle and Frying Pan. So let's say I have in production a service called the reversal server, which has one endpoint that reverses my string. The version that is currently deployed is 1.14, and I see it in Lifecycle, and I see it in Frying Pan. And so I go to my controller, and I simply add another endpoint to say hello. I run Bazel test to make sure that I didn't break any of the end-to-end test. I pay the price only of the end-to-end test because everything else is cached. Just to show you that Bazel doesn't do rework, I run Bazel test again, and you can see here that it returned almost immediately and showed me that everything is cached. So I commit my code and I push it into master and let GCB do the build for me. And after a minute, I'll check the result to see that everything went well. I can see the result of the GCB process, and then I can see the result. Of the different Bazel targets that ran in that build. But then I go to Lifecycle, and I see. Let me go to Lifecycle. And I see that there's actually a new RC waiting to be GA'd, because on the new process, any build would be automatically RC. And from this moment on, it's just GAing like before. So I'm GAing, and I can see in Frying Pan that there's a new build waiting to be deployed. I wait a little bit for Chef to deploy my build. And once it's deployed, I go to the new endpoint. And see it's in work. So I really hope this new system would change your everyday work and help you deal with the frustrations you currently have with the build system. And that's it. Thank you. So Komanov caught me in a lie. He asked what happens if two pull request builds are green together and then they get merged into master, and then on the master something breaks. Well, in that situation, master would be broken. And then we'll have to figure out what needs to be done and revert one of them. So yeah, that's an edge, that's an edge case. Yeah, and we're considering automatic rollback, but that use case is still needs to be handled. You're correct. Repeat the question. He asked, what will happen once the master is broken? I'll get broken dependencies? And the answer is yes, but it will happen much less frequent. Yes. So what about Node just less JavaScript support? So Bazel is a very flexible language, and you can write an extension for or find an extension for almost every language, every common language in the market. But there is an effort that needs to be done in order to make it work in our organization. So the plan is to go there, but it requires an effort from that guild. Yes, Dalia. Oh, can I share some of the obstacles we ran into? So first, Bazel is a very young build tool. So we first had to make sure that it works great for weeks, and that's part of the work that I told you that we're doing. I think that the biggest obstacle we have is to migrate all of Wix repositories into Bazel. Work that requires every team at the server guild to do dedicated work. Yeah, sure. Is Bazel still build of choice in Google? Of course, Bazel is been used daily on Google. Yeah, 40,000 engineers are using Bazel in Google. Very good question. Can I develop without internet? Let's say I wrote a test and I'm on a plane and I don't have internet. Can I develop without it? Of course. You have local cache that you can utilize. Of course, you don't get access to the remote cache, but that means that you might need to rebuild some stuff that is on the remote cache. Are we going to have a mono repo for all of Wix? That's a very tough question.
Not in the next
Yeah, not yeah. The right answer is not in the next year. We're not planning on getting it not in the next year. So thank you very much, everyone.